they could watch it later. Okay, so now we are being recorded. Number 2 is part C. Perfect. Yes. Okay. So that is one, and I will show you how to do that. So normal distribution, with normal distribution problems, binomial probability, and these are the ones that I think have a little bit more involved work. And then we have the sampling distribution problems. Oh my gosh. It's not meant to be. Okay, that's fine. I can see all of it up here. So then we have sampling distribution problems. The pen go dead. I'm going to try to find me a marker. And those take a little bit of work, a little more than the normal distribution. So in order to be able to kind of tell these problems apart, and some of you went through that activity, the Desmos activity, and there was a question on there on how do you tell them apart. Your normal distribution will give you the mean and the standard deviation, and then it will ask you to solve some problems about that. The binomial will give you usually a sample size. So it will say maybe n is 100, and it will give you a p-value or a percentage. And then you have to calculate your mean, which is n times p, and your standard deviation, which is the square root of n times p times q. And then, of course, in some of the questions, it did ask you to calculate the variance. And I think it was written as the variance of x, and that is just n times p times q, because variance is what you have before you take the square root to get the standard deviation. So there's also some information about binomial probabilities, and I'm going to flip that over. There are some formulas that we need to know in order to work with binomial probabilities. And so there's these are in your notes in your textbook, but I want to jot them down here. When you are doing binomial probabilities, if it asks you to find, for example, the probability that x is less than 3, we can't just type that in as x is less than 3. We have to type that in as x is less than equal to 2. So your binomial probabilities change forms in how you work with those, and that is what I have seen has caused a lot of the struggle with binomial problems, in just not changing forms on those problems. So if you are doing, for example, x is greater than equal to 5, that changes to 1 minus the probability that x is less than equal to 4. And then if you are doing the probability that x is between two numbers, that is calculated as the probability that x is less than equal to the larger number minus the probability that x is less than equal to 1 smaller than your smallest number. And the reason we have these binomial probability formulas is because binomial charts are cumulative, meaning if you have a binomial chart, I am looking for one here in my stack of charts. So if you have a binomial chart, zoom that in as much as I can. You can't just go in here and read 2 as 0.99, because what that is, when you read 2, that includes 0 and 1 and 2. It is a cumulative value that includes up through 2. So if you want just 2, you basically have to take this 2, what the chart reads for 2, and subtract off 1 and 0, because that then will leave you 2 as standing alone. So that's kind of why we have to change those forms to be able to work with the problems. The other issue that I have seen that most are not doing with putting the binomials into StatCrunch is doing what's called a correction for continuity. And we have to do this because binomial probabilities are discrete. They're not continuous. And so we need to be able to get as close to the value as possible. And so we do what's called a correction for continuity. And what that is that we add 0.5 to our z-score. Subtract, that's a subtract. So your value plus 0.5 minus the mean and divided by your standard deviation. So it is your regular z-score formula, only we are taking our value and adding 0.5. And that is so we can get as much of the value as possible when we work out our probability. So those few things you'll need to know as we work through, and then I think once we work a couple of problems, it'll kind of fill in the gaps for you. Back over here to sampling distribution problems. So these problems give you in the question a mean and a standard deviation. And you have to take that, the mean is given. So you use the mean that's given in the problem, but it gives you an actual standard deviation and it gives you a sample size. And you have to calculate that new standard deviation for the sampling distribution using the given standard deviation and divided by the square root of n. So once you have the given mean and that new standard deviation, then these sampling distribution problems go straight into StatCrunch in the normal calculator. Okay. So after that little bit of background, we can now go on to had a question on number 2. And so the question on number 2 was mainly with part C. And so I am going to show my number 2, part C. In my number 2, it says that my mean is 9.05 hours, and it says that my standard deviation is 2.01 hours. And then my part C says find the value A for which the probability that X is less than A is 0.2. So it gives us the answer, really, and it wants to know what is the value that we're finding that it's less than. So I'm going to go ahead and open up Pearson and go over to StatCrunch, and we will look at how to do this. Okay, so I am going to share my StatCrunch screen. Stop sharing that one. Share this one. And so I am going to do stat and calculator and normal. And okay, and so you can still see that. I'm going to put in my mean of 9.05. I'm going to put in my standard deviation of 2.01. I'm going to take that number out of that box because that's what we're looking for, and I'm going to put the 0.2 in the answer box, and I'm going to hit compute, and I'm getting the answer 7.36. Okay. So the A value in this question, 7.36. So Brittany, I think that was your question. Did that answer everything you needed for that one? Okay, all right. Okay, so looks like the next question on my list is question number 7. And so I am going to do just a number 7 that I have here in front of me. And so I'm going to share back the camera. Now, where did it go? There we are. Okay. So then, my number 7 says, according to studies, 1% of all patients who undergo laser surgery to correct their vision have serious post-laser vision problems. In a random sample of 100,000 patients, let X be the number who experience serious post-laser vision problems. So right away, I know that my P is 0.01. That's the percentage given in the question. That means that my Q is going to be 0.99. So these are things when I'm working with a binomial that I just go ahead and I know I need my P and I know I need my Q. And then I know that I need my sample size, which would be 100,000. And I know that I'm going to need my mean because the first question says to find E of X, and E of X is your expected value, which is also equal to your mean. So E of X is going to be the N times the P. And so that's going to be 100,000 times 0.01. And that should give us 1,000. So that takes care of part A. And then part B asks us to find the variance. And that's going to be N times P times Q. So 100,000 times 0.01 times 0.99. And when we work that out, we should get 990. Let me double check that just to be sure. Okay. Any questions so far? Okay. Part C asks us to calculate the z-score for x equals 940. And here comes the little trick. When we're doing x equals a number, we have to go down 1. So then we're actually calculating for x equals 939. And then because this is a binomial, we have to use that correction for continuity and add the 0.5. So we're actually doing 939.5 minus our mean, which is 1,000, and divided by our standard deviation. But we don't have our standard deviation yet. So we calculated our variance up here. And in order to get our standard deviation, we just have to take the square root of that. So if anybody gets to the square root of 990 faster than I can find my calculator and get it turned on, you can just yell it out or type it in. And I am getting 31.464265545. So we work all of this out. So 939.5 minus 1,000, divide by 31.464265545, getting negative 1.92. Is everybody good so far? I don't see it. Yes, okay. So I have to have that thing open for that to share. That's weird. Yes, okay. All right. So then part D says, find the probability that fewer than 940 patients in a sample of 100,000 will experience serious post-laser vision problems. So finding the probability that fewer than 940, which means we're actually doing less than equal the 939.5. So we go down to 939 because of the rules for binomials, and then we do the 0.5 for the correction for continuity. And then we just go and stick all of this into StatCrunch. So I'm going to share that StatCrunch window again. So then I know that my mean was 1,000. I know that my standard deviation was 31.4642655. Then we're doing less than equal to 939.5, and I'm getting 0.0273. And so what that's giving us is the probability. There's basically a 2.7% probability that fewer than 940 will experience serious post-laser vision problems. So it's a very small chance, and you can see that in the shading in the graph there as well. Okay. Any questions or comments to this point? Okay, so the next question that we were asked was number 9, and number 9 is also a binomial question. So it's going to be very similar to the question that we just completed. So my number 9 says, according to a study, the median time a patient waits to see a doctor in an emergency room is 30 minutes. Number 9 now. Consider an emergency room on a day when 250 patients visit. So right away, I know my sample size is 250. What is my P on this question? This one's a little tricky. So 30 minutes is our rate. 0.5, perfect. So our P is 0.5. And that's because 30 minutes is half of an hour. If you notice, your P and your Q is always a number between 0 and 1, and both of them together have to add up to 1, because one of them is the probability that something's happening, and the other is the complement of meaning it's not going to happen. That's the chance it won't happen. So our P is 0.5, our Q is 0.5, and then because this is a binomial, I am going to go ahead and calculate the mean, so N times P, or 250 times 0.5, which gives us, or sorry, I said 150 here, didn't I? Which gives us 75. Getting your numbers wrong will definitely mess up your problems. Okay. So 150, 75, and then standard deviation, square root of N times P times Q. So square root of 150 times 0.5 times 0.5. And that is giving me 6.123724357. So that's our mean, our standard deviation, we've got our P, we've got our Q. Now the first question says, what is the probability that more than half will wait more than 30 minutes? So we're looking for the probability that more than half of the 150, so probability that more than 75 will wait more than 30 minutes. So because this is greater than 75, we use our rules for binomials, and we say, okay, we're going to calculate 1 minus the probability that x is less than equal to 75. So I'm going to add a new one to your list, because we had already said, okay, greater than equal is 1 minus the probability less than equal the next lower number. So if you're just calculating a greater than, and it doesn't have that equal on the bottom, then it is 1 minus the probability of x less than equal to that value. So the value does not change. So it's good to see the differences in just that greater than equal, and then the greater than causes to happen. Up here, if you want to add another one, the less than equal to 3 is just less than equal to 3, because that means that's going to include everything 0, 1, 2, and 3, and it can include 3 as well. So from here, we've got into our binomial form. The only other thing we want to do is add that correction for continuity. So that's going to be 75.5. We go over to StatCrunch, and when we put this into StatCrunch, is everybody comfortable with putting these into StatCrunch so that I'm not flipping back and forth in the screens, and we can just kind of look at what we would put into StatCrunch? Yes, okay. Everybody else okay with that? Yes, I'm seeing lots of yeses. Okay. So when I put that into StatCrunch, I'm getting out 532533734, and ends up giving me a probability of 4675 if I'm rounding that to 4 places. Okay. So that was part A. Part B is going to be very similar, because it's asking for the probability that more than 85 will wait more than 30 minutes. So the probability of more than 85 means we are working out 1 minus the probability that x is less than equal to 85, which means what we put into StatCrunch is less than equal to 85.5, which gives us 95679463 with an actual probability of 0.0432, or about 4.3%. So you have a very small chance that more than 85 of them will wait more than 30 minutes. Any questions so far? Part C is a little different. Part C is asking what is the probability that more than 60 but less than 90. So basically between 60 and 90. And what I have found, because unfortunately the between calculator, I cannot seem to make the between calculator do these binomials the way we need them to do them. And I need to play around with it a little bit more. So I like to write this as 2 different problems, greater than 60 and less than 90, and then work them out. So greater than 60 becomes 1 minus the probability that x is less than equal to 60, and this becomes the probability that x is less than equal to 89. But then when these go into StatCrunch, you're putting in x is less than equal to 60.5 and x is less than equal to 89.5. So with the binomial, you can't forget that correction for continuity. Okay. And then what happens is when we put these into StatCrunch, so for that top piece, I ended up with 00894613. And the bottom piece, 0.99105387. And then we have to basically subtract these 2 numbers, and we end up with 0.9821. And the reason we have to subtract these, if you draw out the picture, and the picture really, really helps, our mean was 75, so our mean's right there in the middle. If we're looking at basically between 60 and 90, then when we do greater than 60, it's giving us everything that way. And when we do less than 90, it's giving us everything this way. And we have to get basically that middle section, only this middle section that we are concerned with. So if you subtract one from the other, that leaves just that middle section. Okay, so any other questions on number 9? So 10 and 11 are very, very, like students usually say, oh my gosh, I was making that harder than I had to. So here is a number 10 question, and it's asking about probability distribution. It's giving us a chart. Probability distribution describes a population of measurements that can assume values of 1, 3, 5, and 7, each of which occurs with the same relative frequency. So what this is asking us first is how many sample sizes can we make out of 1, 3, 5, and 7? So if we remember back to chapter 3, when we were saying, okay, let's see, x is 1, 3, 5, and 7, how many combinations, how many pairs can I make out of these numbers? And so if you do a tree, so I like to do a tree, You can pair 1 with 1, you can pair 1 with 3, you can pair 1 with 5, and you can pair 1 with 7. And then you can do each of these the same way. You can pair 3 with 1, 3 with 3, 3 with 5, 3 with 7. You can pair 5 with 1, with 3, with 7, and 7 with 1, and 3, and 5, and 7. So we've made 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16 pairs. So we would choose the problem where these pairs are all represented, and I think it turns out to be this one with all of the more choices than the other 2 sets. And so then what we do from there is we say, okay, what is the mean of 1 and 1? What's the mean of each of these pairs of numbers? So 1 plus 1 is 2, and 2 divided by 2 is 1. And so it's asking for just the mean of each set of these numbers. Once you get the mean of each set of those numbers in there, then you're just answering some probability questions about those.
Okay, so mine is 0, 2, 4, and 6, but I just do 0 plus 2 divided by
2.
Okay.
Yes. Yes.
Just making sure.
So everybody okay with that question? Number 11 is very, very similar, except for it's asking for the medians of these numbers. But the median, when you only have 2 numbers, is the same as the mean. So add them up, divide by 2, and that's what's going to go in your top boxes. And so then once you get your medians in there, for example, just choose this one, 0 plus 4 is 4, and 4 divided by 2 is 2. So everything with a median of 2, which would be this one and this one and this one, so everything that adds to 4, you would add those probabilities, and that's what's going to go in this box down here. Then it's going to ask you to do some questions about those. So then we get to 12, 13, and 14, and those are the last 3 questions. And they're probably going to seem like they're really easy. Once we've gone through the binomials, like I said, the binomials are kind of the problem child of this section, and they do take the most work to get them ready to put into StatCrunch. And so my number 12 says, a random sample of 100 observations drawn from a population with a mean equal to 18 and a standard deviation equal to 10. Complete parts A through G below. And so it's asking us first, give the mean and the standard deviation of the repeated sampling distribution. So the mean is always just the given mean that was in the question. So the mean on a sampling distribution stays the same. The thing that changes is the standard deviation. So we're going to take that formula for sampling distribution, standard deviation, and we're going to say, okay, it's going to be the given standard deviation, which was 10, divided by square root of our sample size. So in this case, 10 divided by 10, and that becomes a 1. And then all of these questions go straight into StatCrunch, into the normal calculator, once you've got that mean and that new standard deviation. And is everybody okay with putting those in? Yes, okay. So that's 12. 13 and 14 are exactly the same. They're sampling distribution questions. You know, you start to see, of course, we see the word sampling distribution, and we see these. It seems so easy when you do it. Thank you so much. hopefully it will be easy when you get home. And of course, this recording will be up as well for everybody to watch and rewatch. Great. So that takes us through the end of the section. Does anybody have other questions on anything that we haven't covered? I think we've covered one of every type of question.
Once we get this done, will those quizzes be open for us to take?
I will go ahead for everybody that is here and reopen those quizzes.
Okay.
Yep, I will. So thank you all so much. Any other questions? I mean, I'm here until y'all don't need me. So we're still here at 6 o'clock tonight. We're here at 6 o'clock tonight. Thank you all so much, and hopefully you all are okay with. I will run the quizzes through tomorrow night at least, so you'll have a little bit more than 24 hours. And then if you would need more time, just message me, and that's really no big deal. Okay. All right. If you don't have any other questions, you're free to go, and we'll sign off. And of course, if you have more questions, you can email me. You're very welcome. Sometimes it just helps to see things and fill in some little gaps if you're missing just those little pieces. I know those binomials are a little bit meatier problems with a lot of that work that you have to do to get them ready to go. But you guys are lucky because somehow something changed in StatCrunch. It didn't used to do binomials at all, and so now the last couple of semesters it has worked with the binomials. And so prior to you all, and maybe even last semester, everybody was doing binomials by hand. So yeah, you all are very lucky. You're in the lucky group to be able to use StatCrunch for them. So thank you all for coming, and I hope you have a good rest of your evening. And if you need anything else, just give me an email.